All right, 5.3, solving trig equations, day 2. Before we jump into our specific notes today, I just want to remind you of our generics is that remember to keep in mind things like what your method is, whether that's memorizing quadrant 1, which I'm going to give us a quadrant 1 here, or hand trick or special right triangles. And if you are hand trick or special right triangles, please go ahead and draw those models for yourself, or remember how to do your hand trick. But just a reminder that we're looking for angles. Our answers are angles right now. So if you need to have this chart always handy, do that. That all of those ordered pairs go cosine, comma, sine. If we get into a tangent problem, remember that tangent is sine over cosine. And my other reminder to you then is, okay, well, if it's not in a quadrant, it's on an axis. Your options are to get to 0, 1 comma 0, up here to get to pi over 2, 0 comma 1, to get to the angle pi is negative 1, 0, and 0, negative 1 lands us at 3 pi over 2. If you ever want to answer 2 pi, don't. It's not in the directions. Your directions say from 0 included to 2 pi not included. So if you ever want to say 2 pi, say 0. All right. Today we're going to look at problems that require factoring. And this one is a very basic one where it's already been factored for us. We see that we've got 2 different parentheses here. And we use that zero product property that says if 2 things are multiplied together, one of the 2 of them has to be 0. So what if I set them each equal to 0? So that would give me basically 2 separate problems. Tangent of x plus 1 equals 0. And sine of x minus 2 equals 0. So we just treat them as 2 separate problems. So as I work that first problem, I would, again, solve for my trig function like normal. And I would be finding the angle that gives me a tangent value of 1, which is a positive number. Tangent is positive in quadrants 1 and 3. And the angle that gives us a tangent value of 1, that one that we tend to forget, is pi over 4. Pi over 4 in quadrant 1 is pi over 4. Pi over 4 in quadrant 3 is going to be 5 pi over 4. And then we add to this list as we move to the other side if we have answers to add to the list. You don't put any duplicates, so I would add 2. And it is possible that a particular side of this does not add an answer. I will remind you that sine of x has a range of negative 1 to 1. 2 is not within that range. So this one gives us no solution. No solution is not our answer because we have solutions, but that just means it does not add to our list. So our answers for this problem would just be pi over 4 and 5 pi over 4. Okay, so then sometimes we need to do that work ourselves. On the last one, it came to us factored, and we were ready to just set the 2 parentheses equal to 0. So working our way into that, I just want to show you. We have multiple times leading up to this looked at problems taking out the trig part of it and just looking at them as plain terms. If I were to do this, this would look like sine of a squared plus 2a squared plus 3a equals negative 1. And if I asked you to factor that, you would have said, okay, I need to get it equal to 0 first. And then we would have factored into 2 parentheses with this 2a and a. And we needed to add up to a 3, so plus 1 plus 1. And guys, it's going to be no different when those are trig functions. It gets a little distracting because they're full words, but it's just like if it was an a or an a squared. Okay, so job number 1 is to bring that 1 over. And then we factor So factors of 2 sine x squared would be 2 sine x and 1 sine x. When I multiply those back together, I would get 2 sine squared. Factors of 1 are 1 and 1. And then I would set each of those equal to 0 to solve. So 2 sine x plus 1 equals 0. Sine x plus 1 equals 0. All right, so let's go ahead and solve the one on the left first. I would start by subtracting 1, dividing by 2. Then we have our conversation about where are we getting answers. Okay, this is a sine problem, and it's negative. Sine is negative in quadrants 3 and 4. So for this one, I would have answers from quadrant 3 and quadrant 4. And the angle that gives us a sine value of 1/2 would be pi over 6. The pi over 6 that puts me into quadrant 3 would be 7 pi over 6. And the pi over 6 that puts me into quadrant 4 would be 11 pi over 6. And then we solve our second problem here. So I get sine of x equals -1. Now, -1 is going to put us on an axis. So if I think about each of those angles on our axis, and then think about the second value in each of our ordered pairs, I'm looking for the one that has a second number of -1, and that would be down here at 0, -1. So we would have an answer of 3 pi over 2. So I'm going to come over here and add that to my list. So notice we got 3 answers this time. And I will remind you, order on those answers does not matter. All right, so looking at that one more time, 2 cosine squared x plus 3 cosine x plus 1, very similarly to the last one, except for this time it's going to be cosines instead of sines. And we didn't have to do any work at the beginning there. So again, factors of 2 cosine x would be a 2 cosine and a 1 cosine. Factors of 1 are 1 and 1. And setting each of those equal to 0 to solve. We would subtract 1 over here. Divide by 2. Think about where cosine is negative. Cosine is going to be negative in quadrant 2. Cosine is going to be negative in quadrant 3. So the angle that gives us a cosine of 1/2 would be pi over 3. Pi over 3 in quadrant 2 would be 2 pi over 3. The pi over 3 that would put us into quadrant 3 would be 4 pi over 3. Moving on to our second problem, subtract 1 from both sides. We get cosine of x equals -1, and that again puts us on an axis. So we think about each of our angles on an axis, and cosine is the first number in each of those ordered pairs. So as I find the ordered pair that starts with a -1, that would be over here at -1, 0, which means our answer is an angle of pi. So again, you're going to see that we can have any range of number of answers, all the way from no solution up to 4, 5, 6 or more answers to this. So there's not a set number for each problem, because we could get up to 4 answers for each problem if we were to square root, etc. But solving them basically as 2 separate problems, but listing all the answers together. All right, and our last type is what's going to be called a GCF. And so what I'm going to do is I'm going to get everything onto the same side by subtracting square root of 3 sine x from both sides, so that it's equal to 0. All right, so what we see is these 2 terms over here have a GCF of sine of x, and so I'm going to factor that sine of x out to the front. Taking a sine of x out of each term. And once I have that done, I see that it is completely factored, and so now what I would do is set each of those things equal to 0. We would set sine of x equal to 0, and we would set that parentheses equal to 0. and solve each problem. Sine of x equaling 0 again goes back to our on an axis. Oops. And I'm going to put all these out here. Remember that sine is the second number in each of those ordered pairs. Well, sine equaling 0, which is what we are looking for, happens twice. Sine equals 0 here, but it also equals 0 here, which means from this first one we actually have two answers of 0 and pi. And solving that second equation, we would add square root of 3, divide by 2, and we get a cosine that is positive. So we go to our all students take calc. And we say, okay, cosine is positive in quadrant 1 and quadrant 4. So from this particular problem, we would have answers from quadrant 1 and quadrant 4. The angle that gives us a cosine of square root of 3 over 2 would be a pi over 6. In quadrant 1 is pi over 6. And the pi over 6 that puts us into quadrant 4 would be 11 pi over 6. So then my overall answer would be all of that. 0, pi over 6, and 11 pi over 6. In any order. All right, and I know that says 5.3 worksheet 11 through 18. I just pulled those two apart, so it will be actually labeled as 5.3 worksheet B.